Physics paper question 1. Which of the following units is not that of mutual inductance? Here per Weber, that is option B, is not the unit of mutual inductance. Question 2. Farad is not equivalent to. Now Farad is basically the unit of capacitance. Capacitance is charge by voltage. So option A is right. Potential is work by Q. So basically Q becomes work by V. So I can write here as C can also be Q square by J and C can also be J by V square. That is, J basically represents your work. So the only option that does not satisfy this, that is capacitance equation, is option B. So Farad is not equivalent to QV square. Question 3. A body is thrown vertically up with a velocity u. It passes 3 points A, B and C in its upward journey with velocity u by 2, u by 3 and u by 4 respectively. The ratio of separation points between points A and B and between B and C, that is AB by BC, is. So we have to find the ratio AB by BC. Now there are 3 points. Body is thrown up. 3 points will be something like this. There will be point A, point B and there will be point C. Now at these 3 points, let H1 be the height at A, H2 be the height at B and H3 be the height at C. So H1 height for A, H2 height for B and H3 height for point C. Now for A, B and C, they have given us the velocities. So at A the velocity is u by 2, B it is u by 3 and C it is u by 4. So I can write as u square by 4 minus u square will be equal to minus 2g h1. For point B, u square by 9 minus u square will be equal to minus 2g h2. And for point C, u square by 16 minus u square will be equal to minus 2g h3. Now from these equations I can find AB. AB would be u square by 2g 8 by 9 minus 3 by 4, which will basically give me u square by 2g multiplied by 5 by 36. Same way I'll get BC as u square by 2g 7 by 144, and then when I divide AB by BC, my final answer will be 20 by 7. That is option D would be my correct answer. Question 4. The second hand of a watch has length 6 cm. The speed of endpoint and magnitude of difference of velocities at two perpendicular positions will be. Now we know that V equals R omega, which will be equal to R multiplied by 2 pi by T. R is 0.06 meters multiplied by 2 pi divided by time period. Time period is for the second hand 60 seconds. So this gives us V as 6.28 meters per second. Now magnitude of change in velocity is basically V2 minus V2 bar minus V1 bar modulus. So which basically is root of V1 square plus V2 square, which would be 8.88, as both V1 and V2 would be in magnitude term, they will both be 6.28. So 6.28 square plus 6.28 square under the root, that will give you 8.88 as the answer. So basically speed is 6.28 and difference of velocities at two perpendicular positions is 8.88. So the correct answer is option D. Question 5. The angular speed of a flywheel making 120 revolutions per minute is. 120 revolutions per minute will convert it to revolutions per second. That will be 4, basically 120 by 60. There will be 2 revolutions per second, which would basically mean omega would be 4 pi, basically 2 pi by multiplied by 2, that is 2 pi n, which will give me 4 pi as the answer. So your correct answer would be option D here. Which of the following quantities measured from different inertial reference frame are the same? Here the answer is force. Force is the quantity measured from different inertial frames remains the same. Question 7. A box is lying on an inclined plane. What is the coefficient of static friction if the box starts sliding when an angle of inclination is 60 degree? So coefficient of static friction is basically tan of angle of repose. Your theta is nothing but angle of repose. Here the angle of repose, that is basically an angle of inclination, is given as 60. So that will be tan 60, which is 1.732. So that is option B is the correct answer here. Question 8. A body is moved along a straight line by machine delivering a constant power. The distance moved by the body in time t is proportional to. Now here power is constant. Power is force into velocity. Force is mass into acceleration. So power is mass into acceleration into velocity. So basically I will get an equation which says velocity into acceleration equals to power divided by mass. This acceleration is basically v multiplied by v dv by ds, which is equal to power by mass. Now I can take the ds on that side and integrate both sides. So I'll get, on integrating, I will obtain v cube by 3 equals to power into displacement divided by mass. Now your v would be equal to, from here, 3p divided by m the whole raised to 1 by 3 multiplied by s raised to 1 by 3. Now velocity is nothing but ds by dt, which is equals to, let's say this whole term 3p by m the whole raised to 1 by 3 is nothing but constant, as power is constant and mass is also constant, multiplied by s raised to 1 by 3. Now again taking s on this side, so I'll have 1 by s raised to 1 by 3 ds equals to k dt. Again integrating them would give me the answer as s raised to 2 by 3 divided by 2 by 3 equals to kt. So from here s can be written as 2 by 3k multiplied by t the whole raised to 3 by 2. So basically from here I can say s is proportional to 3 raised to t raised to 3 by 2. So correct answer is option B. Question 9. If a ball dropped from rest, it bounces from the floor. The coefficient of restitution is 0.5 and the speed just before the first bounce is 5 meters per second. The total time taken by the ball to come to rest is, so coefficient of restitution is given, speed just before the first bounce is 5 meters per second. The total time taken by the ball to come to rest is what we have to calculate. Now here acceleration equals v minus u by t. I can write this equation as g would be equal to v minus v0 divided by t. Now v, that is the final velocity, is 0. So this equation becomes v0 would be equal to minus gt. And your v0 value is given as 5 meters per second, that is minus 5 meters per second. So from here I can obtain time as minus 5 by 10, that is basically 0.5 seconds. So time taken would be option C, 0.5 seconds. Question 10. A non-uniform thin rod of length L is placed along x-axis. As such, one of its end is at the origin. The linear mass density of rod is L equals L0x. The distance of center of mass of rod from the origin is. So we have to find how far is the center of mass from the origin. Now, this being my axis, this being my origin, the rod is of length L, is placed along the x-axis. As such, one of its end is at the origin. Linear mass density of the rod is given as L equals L0x. You have to find the distance. Now let the mass be placed, that is the center of mass, be at a distance x from the origin. Now, let that mass be represented by dm, which is nothing but of the length dx. So I can say dm is equal to lambda dx, which is equal to lambda 0x dx. X would be equal to integral 0 to L x dm divided by integral dm, which will be equal to integral 0 to m x lambda 0 x dx divided by integral 0 to L lambda 0 x dx. So integrating, you will get lambda x cube by 3 0 to L divided by lambda 0 x square by 2 0 to L. This on solving you will obtain the answer as 2 by 3 L. So correct answer here is option B, 2 by 3 L. Question 11. A uniform ring of mass m and radius r is placed directly above a uniform sphere of mass 8m and of radius r. The center of the ring is at a distance of d equals root 3 r from the center of the sphere. The gravitational attraction between the sphere and the ring. So now there is a sphere having mass 8m and a ring having mass m. Radius of the ring is r. Radius of the sphere is also r. So capital R is the radius of the sphere, small r is the radius of the ring. Now both the sphere and the ring, the centers of both of them are at a distance of root 3 by r. So we have to find gravitational intensity due to the ring at a distance d equals root 3 by r on its axis. So that gravitational intensity will be gm divided by d square plus r square the whole raised to 3 by 2. Your d is nothing but root 3 r. Substituting that, we will obtain root 3 gm divided by 8 r square. Force on sphere would be mass, that is 8m multiplied by the intensity, which is 8m multiplied by root 3 gm by 8 r square. So the 8 cancels out, so we get root 3 gm square divided by r square. So correct answer is option D. Question 12. A rope 1 centimeter in diameter breaks if the tension in it exceeds 500 Newton. The maximum tension that may be given to similar rope of diameter 3 centimeter is. So for a rope of diameter 1 centimeter, the maximum tension is 500 Newton. We have to find out what will be the tension if the rope diameter is same rope but diameter is 3 centimeter. So now breaking stress on both the ropes would be the same, as both the ropes are of the same material. We can use this relation which says T max 1 divided by pi multiplied by half square, that is basically diameter square, pi d square, would be equal to T max 2 divided by pi, again d square, that will be 3 by 2 square. It is pi r square. So T max 2 would be equal to 9 times T max 1. So your tension in 1 is given to you as 500 Newton multiplied by 9. You will get 4500 as your answer. Question 13. A diagram shows a cup of tea seen from above. That is this diagram. The tea has been stirred and is now rotating without turbulence. A graph showing the speed v with which the liquid is crossing points at a distance x from O. A radius xo would look like. So this is how the tea is swirling. Graph shows the speed v with which the liquid is crossing the point x. Now, so we have to find out which is the graph. So when we move from center to circumference, the velocity of liquid goes on decreasing and finally becomes 0. That is, velocity more towards the edge would be 0, whereas towards the center will be high. So the velocity as you move from the center towards the edge goes on decreasing till it becomes 0. So your correct answer here would be velocity is maximum at the origin and goes on decreasing as you move away from the origin. So your correct option will be option D. Question 14. Water stands at level A in the arrangement shown in the figure. What will happen if a jet of air is gently blown into the horizontal tube? So this is what the diagram looks like. Into this horizontal tube, when a jet of air is blown, we have to find out what happens. So when air is blown in the horizontal tube, the pressure of air decreases in the tube, due to which the water will rise above the point A. So originally the water was at point A. Because of the jet of air, the water will rise at point A. So your correct answer here would be option A. Water will rise above A in the capillary tube. Question 15. A block of mass 100 grams slides on a rough horizontal surface. If the speed of the block decreases from 10 meters per second to 5 meters per second, the thermal energy developed in this process would be. Now, according to law of conservation of energy, change in kinetic energy appears in the form of heat. So, when it is moving, basically the kinetic energy that is responsible for the heat produced. So, your kinetic energy, that is the thermal energy, would be nothing but the change in kinetic energy. So thermal energy would be equal to half m v1 square minus v2 square. So here I will have half multiplied by 100 into 10 raised to minus 3, converting the gram to kg, v2 square, that is v1 square, that is 10 square minus 5 square, which will give you the final answer as 3.75 joules. So your correct answer here is option A. Question 16. 5.6 liters of helium gas at STP is adiabatically compressed to 0.7 liters. Taking the initial temperature to be T1, the work done in the process is. Now, here 5.6 liters of helium gas at STP is adiabatically compressed to 0.7 liters. So 22.4 liters of any gas is 1 mole. So 5.6 liters would basically mean it is 1 by 4 mole. So your N is nothing but 1 by 4 moles. Now in adiabatic process, temperature into volume raised to gamma minus 1 equals to constant. So I will have T2 V2 raised to gamma minus 1 equals to T1 V1 raised to gamma minus 1. Now I can say, and gamma is nothing but Cp by Cv. So from here I can say T2 is equal to T1, 5.6 divided by 0.7, the whole raised to 5 by 3 minus 1. So basically your T2, on solving this, you will get 4 times T1. Further, in adiabatic process, Q is equals to 0. So work plus change in internal energy is equals to 0. So basically this means work is equal to minus delta U, which is equal to minus NCV into delta T, which would be equal to minus N R divided by gamma minus 1 T2 minus T1. T2 is 4 times T1. Substituting that, gamma value is 5 by 3. N is 1 by 4. Substituting all those values will give you a final answer as minus 9 by 8 RT1. So correct answer is option A. Question 17. Efficiency of carrot engine is 100% if. Now, efficiency is given by the equation 1 minus T2 by T1. For 100% efficiency, this eta value, that is the efficiency value, is 1, which will happen when this whole term is basically 0. So when will this term, that is T2 by T1, is 0? T2 by T1 will be 0 when T2 is equals to 0. So when T2 is 0, efficiency of carried engine is 100%. That is option B is your correct answer. Question 18. RMS velocity of a particle is C at a particular pressure P. If pressure is increased 2 times, then the RMS velocity becomes. Now RMS velocity is independent of pressure and it depends on temperature. So the RMS velocity would remain same. That is, correct answer would be option B. Question 19. The bob of a pendulum of length L is pulled aside from its equilibrium position through an angle theta and then released. The bob will then pass through its equilibrium position with a velocity speed v, where v equals. Now, when the bob of a pendulum is brought to a position making an angle theta with the equilibrium position, then height of fall of pendulum will be, that is, h would be equal to L minus L cos theta. This h is basically, if this is my originally where the pendulum was in the equilibrium position, this side pendulum I take it here. So this height is basically h equals L minus L cos theta. So which is L common 1 minus cos theta. Taking free fall, u will be equal to, initial velocity is 0. Since it's free fall, acceleration will be, a will be equal to g. So I will have v square equals to u square plus 2gh. Your u is 0, your h value is known, g will be as it is, so you will get 2gl 1 minus cos theta. So v square is equal to this, so v would be equal to 2gl 1 minus cos theta under the root. So your correct answer here is option A. Question 20. Which of the following figure represents damped simple harmonic motion? So we have to identify which of these following figures represent a damped simple harmonic motion. Now, what is a damped simple harmonic motion? A motion in which whose amplitude will go on continuously decreasing with time. So if you see the figure A, the first figure, here the amplitude is going on decreasing. So this is basically a damped simple harmonic motion. Simple harmonic, so there has to be, it needs to be a periodic motion, and it is, amplitude is going on decreasing with time, hence that is a damped simple harmonic motion. That is, this option A is your correct option. It is figure 1 alone. Question 21. A source of sound is falling under gravity. At some time t equals to 0, the detector lies vertically hollow sources at a depth h as shown in the figure. If v is the velocity of sound and f0 is the frequency recorded after t equals 2 seconds, is. Now here v will be equal to u plus at. So vs is equal to 0 plus g into 2, which is 2g. As the source is moving towards the observer, f would be equal to v divided by v minus vs f0, which will be equal to v f0 v minus 2g. So a correct answer here is option D. Question 22. On rotating a point charge having a charge q around a charge small q around a charge capital Q in a circle of radius r, the work done will be. So we are rotating a point charge which is small q around a charge capital Q in a circle of radius r. So basically this is small q. I am rotating this charge around capital Q in a radius that is r. When a charge is moved from one point to other over an equipotential surface, work done will be 0. So the work done in this case would be 0. Question 23. 100 capacitors each having capacity of 10 microfarad are connected in parallel and are charged by a potential difference of 100 kilovolt. The energy stored in the capacitors and the cost of charging them if electrical energy cost 108 paise per kilowatt hour will be. Now energy stored in the capacitors will be half CV square multiplied by 100 because there are 100 capacitors, which will basically be half multiplied by C, that is 10 microfarad, that is 10 into 10 raised to minus 6. V is given as 100 into 10 raised to 3 the whole square multiplied by 100, as there are 100 capacitors. This will give you a final answer of 5 multiplied by 10 raised to 6 joules. Electric energy cost 106 paise per kilowatt hour. So that basically means cost of energy is 108 paise divided by 3.6 multiplied by 10 raised to 6. So total cost of charging will be 5 multiplied by 10 raised to 6 into 108 divided by 3.6 into 10 raised to 6. That will basically give you your answer as 150 paise. So correct answer here is option C, which is 5 into 10 raised to 6 joules of energy and 150 paise is the cost. Question 24. Identify the wrong statement. Now, statement A is the electrical potential energy of a system of two protons shall increase if the separation between the two is decreased. B says the electrical potential energy of a proton-electron system will increase if the separation between the two is decreased. So in this case, two protons, it says electrical potential energy of the system will increase when the distance between them is decreased. Here it says between a proton and an electron, same thing, electrical potential energy will increase if the distance between them is decreased. Here it says the electrical potential energy of a proton-electron system again will increase if the distance between them is increased. Here it says electrical potential energy of a system of two electrons will increase if the distance between them is decreased. Now potential energy is given by Q1, Q2 divided by 4 pi epsilon 0 R. So potential energy is inversely proportional to R. So when R decreases, U will increase. Moreover, potential energy as well as force is positive if there is repulsion between the particles and negative if there is attraction. So here your correct answer would be option C, that is for a proton-electron system, that is for the charges or opposite, that is there is attraction, so the potential energy is negative, and hence basically electrical potential energy of proton-electron system will increase if the separation between the two is increased. Question 25. A uniform wire has resistance 24 ohm. It is bent into the form of a circle. The effective resistance between the two end points of any diameter of a circle is. Now resistance of the uniform wire is 24 ohm. When the wire is bent in the form of a circle, that is the wire is bent in the form of a circle, is nothing but two resistors in parallel, two equal resistors in parallel. So this will basically mean there is a 12 ohm resistor here, there is a 12 ohm resistor here in parallel, that is the 24 can be broken into 12. Now since 12 and 12 are parallel, the effective resistance will be 6 ohm. So a correct answer would be option A. Question 26. Steady current flows in a metallic conductor of a non-uniform cross section. The quantity or quantities constant along the length of the conductor is or are. Now, that is, we have to check whether current, electric field and drift velocity are constant, or only drift velocity is constant, or only current and drift are constant, or only current is constant. Now, here only current through the conductor of non-uniform area of cross section is constant. Drift velocity or drift speed will vary inversely with the area of cross section. So here your correct answer would be option D. Question 27. If two electric bulbs have 40 watts and 60 watts rating at 220 volts, then the ratio of their resistances will be power rated is inversely proportional to resistance. So R1 by R2 is equal to P2 by P1, which will be 60 by 40, which will be 3 by 2. So your correct answer here is option D, 3 by 2. Question 28. A thin circular wire carrying a current I has a magnetic moment capital M. The shape of the wire is changed to a square and it carries the same current. It will have a magnetic moment. So initially it was a circular wire, capital M magnetic moment, I is the current, now it's changed in the form of a square. So here, initially for the circular coil, the length of the coil will be 2 pi r. Magnetic moment hence would be 1 multiplied by pi r square. That is I multiplied by pi r square, which is basically I multiplied by pi L by 2 pi the whole square. So you get the answer as I L square divided by 4 pi. Now in case of a square, M dash would be I multiplied by L by 4 the whole square, which is I L square by 16. So M is I L square by 4 pi, M dash is I L square by 16. Now when I relate both of them, I would get M dash would be equal to pi M by 4. So the correct answer would be option D. Question 29. The susceptibility of a paramagnetic material is K at 27 degrees Celsius. At what temperature will its susceptibility be? K by 2. Now for a paramagnetic material, K is inversely proportional to T. So basically K2 by K1 will be equal to T1 by T2. Now K2 becomes K1 by 2 divided by K1. It should be equal to, original temperature was 27 degrees Celsius, which is 27 plus 273 divided by T2. So from here we would obtain the value of T2 as 600 Kelvin. 600 Kelvin minus 273 will give you 327 degrees Celsius. So your correct answer would be option D. Question 30. The mathematical equation for magnetic field line of force is, option A is your correct answer, that is del dot B equals to, that's a scalar product of del and B equals to 0. Question 31. A solenoid 60 mm long has 50 turns on it and it's wound on an iron rod of 7.5 mm radius. Find the flux through the solenoid when the current in it is 3 ampere. The relative permeability of iron is 600, that is given to us. Now phi is equals to, that is flux, mu r mu 0 n square by L multiplied by AI. So relative permeability of iron is given as 600, so that will be mu r 600, mu 0 is 4 pi multiplied by 10 raised to minus 7, n is 50, your A will be 50 pi multiplied by 7.5 into 10 raised to minus 3 the whole square, that's the radius, multiplied by 3, that's your current, divided by L, that's the length, that is 6 into 10 raised to minus 1. On solving this, you will get 1.66 multiplied by 10 raised to minus 3 Webers. So basically that means 1.66 milliwebers. That is option C is your correct answer. Question 32. In LCR circuit, in the condition of the power factor is maximum in an LCR circuit when? Now for an LCR circuit, when XL is equals to XC, the circuit behaves like a resistive circuit, because of which power becomes maximum. So for a purely resistive circuit, the power is maximum and the power factor is 1 when XL is equal to XC. Hence the correct answer would be option A. Question 33. An AC supply gives 30 volt RMS which passes through a 10 ohm resistor. The power dissipated in it is. Now power dissipated is V RMS square divided by R. Substitute your values. You will get 90 watt as the answer. Option B would be the correct answer. Question 34. A layer of ionosphere does not reflect waves with frequencies greater than 10 MHz. Then maximum electron density in this layer is. Here the correct answer would be option A, that is 1.23 multiplied by 10 raised to 11 per meter cube. Question 35. A ray of light passes through an equilateral prism such that the angle of incidence is equal to angle of emergence and the latter is equals to 3 by 4 the angle of prism. So angle of incidence equals to angle of emergence, which is 3 by 4 times angle of prism. The angle of deviation is, so we know I is equal to angle of prism plus angle of deviation divided by 2. Now here angle of the prism is 60 degree. So from that we can obtain I. So I would be 3 by 4 into 60. Substitute, you will get the value of delta m. So delta m, that is angle of deviation, would be 2 multiplied by 3 by 4 multiplied by 60 minus 60 degree, which will be 30 degree as the answer. So correct answer would be option B, 30 degrees. Question 36. The resolving power of an astronomical telescope is 0.2 seconds. If the central half portion of the objective lens is covered, the resolving power will be. Resolving power is given by A divided by 1.22 lambda. Lambda remains same, central half of the objective lens is covered, the resolving power would be. So half of the objective is covered. So A reduces by half. So correct answer would be 0.1 second. Resolving power also reduces by half. Question 37. If I0 is the intensity of the principal maxima in the single slit diffraction pattern, then what will be the intensity when the slit which is double? So in case you divide the original slit into n strips and represent the light from each strip where it reaches the screen by a phasor, then at the central maxima in the diffraction pattern you add n phasors, all in the same direction and each with the same amplitude. The intensity is therefore n square. If you double the slit width, you need 2n phasors. If they are each to have the amplitude of the phasors you used for the narrow slit, the intensity at the central maxima is proportional to 2n the whole square. Therefore, it will be 4 times the intensity for the narrow slit. That is, this will basically be I is proportional to 4n square. That's why you will have the intensity as 4 times the original one, 4 times I0. Because option D would be a correct answer. So when the slit width is doubled, your intensity becomes 4 times. 38. The work function of a substance is 4 eV. The longest wavelength of light that can cause photoelectron emission from this substance is approximately. Now lambda 0 basically is hc by work function. So 12400 divided by the work function, which is 4, will give you 3100 Armstrong, which is 310 nanometers. The correct answer is option C. Question 39. If the work function for a certain metal is 3.2 multiplied by 10 raised to minus 19 joules and it is illuminated with a light of frequency 8 multiplied by 10 raised to 14 hertz, the maximum kinetic energy of the photoelectron would be. So maximum Ke would be h nu minus work function, which is 6.63 multiplied by 10 raised to minus 34 multiplied by the speed of light, multiplied by the frequency that is given, 8 into 10 raised to 14, minus the work function 3.2 multiplied by 10 raised to minus 19. So the final answer would be 2.1 multiplied by 10 raised to minus 19 joules. So correct answer is option A. Question 40. An alpha nucleus of energy half mv square bombards a heavy nuclear target of charge Ze, and the distance of the closest approach for the alpha nucleus will be proportional to. At a distance of closest approach, relative velocity of two particles is v. Your target is considered as stationary, so alpha particle comes to rest instantaneously at distance of closest approach. Let the required distance is r. Then the work energy theorem we will have 0 minus mv square by 2 equals to 1 minus 1 by 4 pi epsilon 0 Ze multiplied by Ze divided by r. That is basically your r from this equation would be inversely proportional to m. It will also be inversely proportional to v square and it will be directly proportional to Ze square. So your correct answer here would be option B. Question 41. An electron jumps from 4th orbit to the 2nd orbit of hydrogen atom. Given the Rydberg constant r equals 10 raised to 5 per centimeter, the frequency in hertz of the emitted radiation will be. Now 1 by lambda equals r, 1 by 2 square minus 1 by 4 square. So this will give me 3r by 16, which will be your lambda would be 16 by 3 r. 16 by 3 multiplied by 10 raised to minus 5 centimeter would be your answer for lambda. That is the wavelength. Frequency would be c by lambda. So 3 multiplied by 10 raised to 8 divided by the wavelength value, that is 16 by 3 multiplied by 10 raised to minus 5. So your frequency will come out to be 9 by 16 multiplied by 10 raised to 15 hertz. So correct answer is option C. Question 42. The mass defect in particular nuclear reaction is 0.3 grams. The amount of energy liberated in kilowatt hour is, velocity of light is given. Mass defect, that is delta m, is 0.3, which will be equal to 0.3 multiplied by 10 raised to minus 3 kgs. Energy liberated will be delta mc square. Substitute all the values, delta m and delta c values. So we will obtain 27 multiplied by 10 raised to 12 joules as the answer. Converting it to kilowatt hour, you will get 27 multiplied by 10 raised to 12 divided by 3.6 multiplied by 10 raised to 6. So your final answer would be 7.5 multiplied by 10 raised to 6 kilowatt hour. So option D would be your correct answer. Question 43. In a triode amplifier, mu is 25, Rp is 40 kilo ohm and load resistance RL is 10 kilo ohm. If the input signal voltage is 0.5 volt, then output signal voltage will be. Voltage gain is equals to V out by VA, which is mu by 1 plus Rp by RL, which will be equal to V out by V in. Input voltage is 0.5. We know Rp, we know RL, we know mu. We can find V out. From here on solving, V out will be obtained as 2.5 volt. Question 44. An optical fiber communication system works on a wavelength of 1.3 micrometers. The number of subscribers it can feed if a channel requires 20 kilohertz are. So optical source frequency would be C by lambda. Substitute the values, you get 2.3 multiplied by 10 to 14 hertz as the frequency. Number of channels or subscribers will be 2.3, that is this frequency, divided by feed channel requires 20 kilohertz, so divide by that 20 kilohertz, so we will get, so 2.3 multiplied by 10 to 14 divided by 20 into 10 to 3, that will be 1.15 multiplied by 10 to 10 channels. So option B would be our correct answer. Question 45, laser beam is used for locating distant object because. Now laser is nothing but light amplification by stimulated emission of radiation. A laser is an optical source that emits photon in a coherent beam. The property of coherent beam is used in many military applications. Now since the laser beam typically has low divergence, that is it spreads less, the laser light appears as a small spot even at a long distance. So here a laser beam is actually used to locate distant object because it is a highly coherent beam of light. Hence your correct answer would be option B.